Welcome to our exploration of nuclear fusion and its potential to address the energy crisis. In this video, we will delve into the fascinating world of fusion, contrasting it with fission, and highlight its benefits such as abundant fuel supply and minimal carbon emissions. We'll also discuss the extraordinary energy output it promises, alongside the inherent safety of fusion technology. However, it's not without its challenges, as we'll examine the high temperatures and containment issues that still need to be overcome. Join us as we look at recent breakthroughs that bring us closer to realizing commercial fusion and its role in a sustainable energy future. 1. Fusion is the opposite of fission. Nuclear fusion and fission might sound similar, but they are fundamentally opposite processes. While nuclear fission breaks heavy atoms into smaller ones, fusion does the exact opposite by combining light atoms like hydrogen isotopes to form heavier ones. This union releases massive amounts of energy, which is the primary reason stars, including our Sun, shine so brightly. Think of fusion as nature's powerhouse, providing a sustainable and nearly limitless source of energy. It's like having a tiny sun on Earth, harnessing the same reactions that fuel the stars. Due to its potential, fusion is increasingly seen as a promising avenue to address our growing energy needs. 2. Abundant fuel supply. One of the most attractive aspects of nuclear fusion is the abundance of its fuel supply. The primary fuels used in fusion reactions are isotopes of hydrogen, namely deuterium and tritium. Deuterium is found in seawater, making it incredibly abundant and accessible. Tritium, on the other hand, can be bred from lithium, which is also widely available. To put it into perspective, a single liter of seawater has the potential to produce as much energy as 300 liters of oil. This means that, theoretically, our oceans could supply energy to humanity for millions of years without the risk of depletion. 3. Virtually zero carbon emissions. In today's world, where environmental concerns are at the forefront, nuclear fusion stands out as an exceptionally clean energy source. Unlike fossil fuels, fusion does not produce greenhouse gases, which are the primary culprits of global warming. Moreover, fusion does not generate long-lived radioactive waste, a significant drawback of nuclear fission. The byproducts of fusion reactions are primarily helium, a non-toxic and inert gas. This makes fusion an environmentally friendly option that could play a vital role in reducing our carbon footprint and combating climate change. 4. Extremely high energy output. The energy output of nuclear fusion is nothing short of extraordinary. Fusion reactions can release up to 4 million times more energy than typical chemical reactions, such as burning coal or oil. This means a small amount of fusion fuel can produce vast amounts of energy, making it an incredibly efficient process. Imagine a few grams of fusion fuel powering an entire city. That's the potential we're talking about. This high energy output could revolutionize the way we produce and consume energy, providing a reliable and virtually inexhaustible power source. 5. Fusion is inherently safe. Safety is a paramount concern when it comes to nuclear energy, and fusion offers a significant advantage in this regard. Unlike fission reactors, fusion reactors cannot suffer from catastrophic meltdowns. If something goes wrong, the fusion reaction stops automatically because it requires very specific and challenging conditions to be sustained. It's akin to trying to keep a fire going without enough oxygen; it simply fizzles out. This inherent safety feature makes fusion an attractive option for producing energy without the risks associated with traditional nuclear power. 6. Key challenges. High temperatures and containment. Despite its many advantages, achieving nuclear fusion on Earth is no easy feat. Fusion requires temperatures exceeding 100 million degrees Celsius, hotter than the core of the Sun, to overcome the repulsive forces between atomic nuclei. This extreme heat is necessary to initiate and sustain the fusion reaction. To contain this incredibly hot plasma, scientists use magnetic confinement methods, like tokamaks, or inertial confinement, which involves lasers. However, maintaining the stability of the plasma remains a significant challenge. It's like trying to hold a blob of jelly with a rubber band. Keeping it intact and stable is no small task. 7. Breakthroughs are accelerating progress. In recent years, remarkable advancements have been made in the field of nuclear fusion, bringing us closer to realizing its potential. Innovations in superconducting magnets, plasma physics, and laser technology have significantly advanced our understanding and capabilities. In 2022, a monumental milestone was achieved at the Lawrence Livermore National Laboratory, fusion ignition, where the energy produced surpassed the energy input required to drive the reaction. This breakthrough has renewed hopes and excitement in the scientific community, fueling efforts to make fusion a viable energy source. 8. Commercial fusion is getting closer. The dream of commercial fusion energy is no longer a distant fantasy. Projects like the International Thermonuclear Experimental Reactor, ITER, and private companies such as Helion and Commonwealth Fusion Systems are actively working towards making fusion reactors commercially available by the 2030s. While the initial costs of developing fusion technology are high, the promise of an almost unlimited supply of clean energy makes it a worthwhile investment. The potential benefits of fusion energy are immense, and the race to harness this power is gaining momentum, bringing us closer to a future where energy scarcity is a thing of the past.